Welcome to Unit 7, Cartesian Vectors, Lesson 5, the cross product. So before we have seen this formula here, this formula is the dot product. What does a dot product represent? Well, it just represents the magnitude of cos theta, or cos A magnitude of cos theta, times the magnitude of B. So it just represents this magnitude times this magnitude. No direction. It is a scalar. So what does magnitude of A, magnitude of B, sine theta represents? Well, to start this off, we're actually going to start by putting the theta there. And so because it's sine, it is actually, we're going to have the opposite side here. So let's call this side here. We'll call this side x. Didn't mean to write in yellow. That's okay. So the side is x. So then I know that sine theta is equal to x over magnitude of A. So that means that x is equal to magnitude of A sine theta. What does that mean? Well, that means this, that basically the magnitude of A, magnitude of B, sine theta just represents, and here I'll highlight it in green. It means we're multiplying this times magnitude of this. All right. Well, what is that? Well, let's go to the next slide and find out. So here, this is the cross product again. The cross product is the magnitude of the cross product is the area of the, and if I take this vector here, oops, if I take this vector here and move it over here, so I get this, and then I take the base vector, move it up here, I've got a parallelogram, and then of course, if I have the magnitude of A, magnitude of B, sine theta, so it's going to be this times this, so really base times height, and that is really the area of a parallelogram. The direction of the cross product gives you a vector, unlike the dot product, which just gives you a scalar. Direction of the cross product, how much of a direction, is orthogonal to both vectors A and B. So what does that mean? That means that I have a vector here that comes out of here that is orthogonal to both A and B, so it must be coming either out of the page, which I can't show you, or into the page. The symbol n refers to the normal, and then that is the orthogonal to both A and B. So the normal is that, and it's an n hat, like looking like that. All right. So how do we find out which way the normal goes? This is really, we're talking geometric vectors here, the right-hand rule. If you do A cross B, the first vector will always be your index. The second vector that you're crossing will always be your middle finger, and then the direction of your thumb is the direction of the normal. So here we go. If I do this one here, I'm looking at the first one. If I put my index finger on A and my middle finger on B and do a little bit of hand yoga, I can see that my thumb is coming out of the page. So this is out of the page. We use this symbol here. Same thing here. If now I put my index finger on A and my middle finger on vector B down here, I can see that my thumb must go into the page. Again, you have to move your hand a little bit. So your thumb is pointing into the page. We use this symbol here. Again, I like to think about the first symbol up here, the circle with a dot, is like an arrow coming at you. You can see the point of the arrow and the rest of the arrow behind it. This arrow, this one here, I think about an arrow going away from me, so I can see that X there looks like the feathers coming away, going away from me. All right. The cross product, so that was for geometric vectors. Here for cross product for Cartesian vectors, we use this formula here, which of course is not very fun to use, but here it is. If you want, you got it. We'll give you a formula sheet with that on it, but why memorize it when you can do it quickly, or even use a formula sheet because you're going to be searching around for it. So here is a visual device to do this. So what I do is, if it's A cross B, I'll write my vector A first. I'll do a few examples numerically, but this is what I do. Write my vector A first, underneath ijk, and then I'll write my vector B underneath that. There we go. And then I start at I, and I go down like this. So I is equal to A2 times B3, and then I'll send up going up. So minus B2 times A3. And then I'll do, that's my first one. My second one will be from the J, so this is the middle coordinate, so A3, B1 minus, and then going up to J, so B3 minus B3 times A1. And then finally K, so it'll be A1 times B2 minus, and then going up to K, so I've got this blue line here, B1 minus A2. So the green represents going down, minus going up, middle, going down from J, going up to J, and then the last going down from K and going up from K. Alright, so here are some properties of the vectors. If I give you vector u, v, and w, and a scalar k. Now please note here, the first one is actually incorrect, so please fix it. U cross v is not equal to negative u cross v. It is equal to negative v cross u. If I give you u cross v, to calculate it using geometric vectors, again this is a geometric vector formula here, magnitude of v, sine theta, and then n hat again. N hat is either going into the page or out of the page, or we can use this formula here, which we'll be doing this majority of the time because this is for our Cartesian vectors. Finally, u cross v plus w, we can distribute that u, so you can go to that one and go to that one, and so u cross v plus w is u cross v plus u cross w. Alright, so some examples. We'll do example 1 and 2, and then for example 3 and 4 I'll create another video for that. So here it says determine the cross product given the magnitude of the two vectors and the angle between them. So this is geometric vector example. So if I want to use u cross v, so u cross v will be equal to the magnitude of u, magnitude of v, and then sine theta n hat. So here I'm going to have 20 times 30 sine of the angle between it as they are tail to tail. N hat, we'll figure out n hat at the very end, so this is going to be equal to, put this in my calculator, I get 385.7 n hat. What is my n hat? So again, since u is first, use my index. So it's my index finger. This is my middle finger. I line it up. So u is on here, or my index finger is on here. My middle finger is on here, and if I do it with the right hand, I can see that it's going into the page, so it's going to be a circle with an X through it. That means it's going into the page using the right hand rule. Alright, if I want to do the other one, so here I want to do V cross U. So I'm going to do the same thing here, so I'm going to skip the formula, so it's going to be 30 times 20, sine of 40, n hat, and again this is going to be the exact same number, so it's going to be 385.7, and then the n hat, well, now this is my index, this guy here is my middle finger. If I do that, again using a little bit of hand yoga, I can see that it's actually coming, my thumb will be coming out of the page, so circle with a dot. That's for geometric vectors. So I have a magnitude and I have a direction. Magnitude and direction. Alright, let's do it for given two position vectors. So here we're back to Cartesian vectors. So I'm going to start with, I want to find A cross B, so I'm going to do I, J, K, I, J, K, and then I'm going to write my first one. It's A cross B, so I'm going to do A first, so 7, 1, negative 2, 7, 1, negative 2, and then my B vector, so it's going to be 4, 3, 6, 4, 3, 6. I'm going to multiply, so I'm going to start with the I and go down, and then I'm going to go back diagonally up through the I. So that one right there, that's my first coordinate. So my vector A cross B is equal to, first one is going to be 1 minus negative 6. There's my first one, comma. Do the next one in green. So I'm going to start at J going down, then back up J going this way. So I'm going to have here for this one, I am going to have negative 8 minus 6 times 7 is 42. And the last one I will do in, well, let's do purple. So I'm going to have here this one going down from K and then going back up to K. So this one here I'm going to have 7 times 3 is 21 minus 4. And then I write it out as 1 minus negative 6, so that is 7. Negative 8 minus 50, or 42 is negative 50. The final one is going to be 21 minus 7 is 17. So that is, this vector here is A cross B, and this vector here is perpendicular to both A and B. And I believe that's the next question. The next question says this. It says, show that A cross B is orthogonal to both A and B. After this example here, I will stop the video and we'll start the last two examples on the next video. So A cross B is orthogonal to A and B. So here I want to show, for the first one, I want to show that A, so if I want to show they're orthogonal, I want to show their dot product is equal to 0. So I'm going to do A dot A cross B. So what's this mean? This means I'm going to do A vector A, which I've forgotten already, is 7, 1, negative 2. So 7, 1, negative 2, dotted with 12, negative 50, and 17. So I'm going to dot them together. So 7 times 12 we'll begin with. Plus 1 times negative 50, plus negative 2 times 17. And if we do this, we get, of course, 0. So there I can show that A is orthogonal to A cross B. Now let's do the other one. So now I'm going to do B dotted with A cross B. So here, this is going to be equal to, vector B is actually equal to 4, 3, 6. So I'm going to have 4, 3, 6, dotted with 12, negative 50, 17. So here we go. I'm going to have 4 times 12 plus 3 times negative 50 plus 6 times 17. If I do this, and voila, I get 0 as well. So I've shown that B is orthogonal to A cross B, A is orthogonal to A cross B as well.